Assalamu alaikum students. In today's video we will try to cover up exercise 1.3. So let's begin. Question number 1 is factorize. Part number 1 is z square plus 169. We can write it like this. Actually we are not able to sort it out, so we will multiply minus minus 1 multiply by minus 1, because we know that minus 1 when multiplied with minus 1 gives you the answer plus 1, so it doesn't make any difference to it. Now this plus minus will be turned into minus, and instead of this minus we will write iota square. Okay, so this is 13 iota square. Okay, so now we will apply the formula a square minus b square equals to a minus b and a plus b. So solution set for this expression is z plus 13 iota and z minus 13 iota. Part number 2 is 2z square plus 18. First we will divide it with 2. The whole expression when divided by 2 gives you z square plus 9. And we all know that 9 is the perfect square of 3. So now we will again do this step, minus 1 into minus 1. So minus, and there it will become 3 iota square. 3 square into iota square. And 3 square into iota square can be written as 3 iota whole square. And now again we will apply the same formula, z plus 3 iota and z minus 3 iota, this formula. So solution set will be z plus 3 iota and z minus 3 iota. In question number 3 we will do again the same steps as we have done in question number 2. Dividing the whole expression with 3 gives you 363 divided by 3 gives you 3 into 1 is 3, 3 into 1 is 3, 3 into 2 is 6, 3 into 1 is 3, 121. And we know that 121 is the perfect square of 11. And as we cannot solve this expression further, so we have to put it like we will multiply minus 1 into minus 1. The one minus 1 will be left here, and the second minus 1 will be turned into iota square. So we will have 11 square and iota square, will combine it like this. Okay, and the solution set will be consisting of z plus 11 iota and z minus 11 iota. Z square plus 3 by 25. Apply minus 1 into minus 1, which equals to 1 instead of this plus. Then minus will be here, 1 minus will be here, and the second minus 1 will be turned into iota square, as we know that minus 1 is equal to iota square. And instead of this 3 will be here, and instead of this 25 we can write 5 square, because 25 is the perfect square of 5. This is minus. Okay, now we want to make this whole expression into square, but this 3 is like creating a problem. What we will put square root and square both on this 3, because square root and square both cancels each other. Iota square and divided by 5 square. Now see, this will be like square root of 3 with iota divided by 5 and whole square. Now this expression is like a square minus b square, which can be written as a plus b and a minus b. This can be written as a plus b and a minus b. This is our solution set. Okay. Part number 6 is z cube minus 7z plus 6. Here we will check that what are the multiples of 6, like what are the numbers which can divide 6. This is 1 and 2 and 3 and the 6 itself. So among them we have to do synthetic division and 1 is applicable for it. How? Because when we put 1 here, 1 cube minus 7 into 1 plus 6 will give you 1 minus 7 plus 6, and 6 plus 1 is 7, 7 minus 7 is 0. So synthetic division is applicable for this for 1. So here we go with 1 minus 7 and 6. Okay, the coefficients, only the coefficients we are going to write, and the root which we are considering is 1, so we will put it here. Now the synthetic division is a bit like this. Put this expression down, multiply these both, and then add subtract here. Minus 7 plus 1 is 6, and put the sign of the bigger number. Now again minus 6 into 1 is minus 6. Again plus minus will be cancelled, so 0 is the answer. So what is the root? Z cube minus 7z plus 6 is equal to z minus 1, this one, and the second expression will be z square minus 6z. Okay, so we know that z minus 1 is easy to solve, and z square minus 6z, we have to take z common from it, then that will be z into z minus 1 and z square, sorry, not z square, z minus 6, because 1z is already taken. So this is the solution set of question number 6. Part number 7 is z cube plus 2z square minus 23z minus 60. Now if we check, then minus 3 will be best applicable on this. Minus 3 cube plus 2 into minus 3 square minus 23 into minus 3 minus 60. I'm going to calculate it. 0 on the calculator when we calculate it. So it's okay. The expression is 1, 2, minus 23 minus 60, and we are going to apply minus 3 for it as a root. First write 1 as it is, then multiply 1 into minus 3, that is minus 3. Now add subtract. This has plus sign and this has minus sign. So we are going to do the subtraction operation. 3 minus 2 is 1, and the bigger number has minus sign. 3 into 1 is 3, and here minus into minus is plus, minus plus minus. 23 minus 3 is 20. We will put the negative sign here because the bigger number has negative sign. Minus into minus is plus. 20 multiplied by 3 is 60. So as you see the number is same and the sign is different, so the answer is 0. So the first root for it is z plus 3, and the second root for it is z square minus z minus 20. Z plus 3 cannot be further simplified, so we can do this. We have to factorize this expression. We know that into 5 is 20, and we also want to get minus 1 as an answer. So this is minus 5z plus 4z minus 20. Because minus 5z plus 4z will give you minus 1 as an answer, and 5 into 4 is 20, so this is also. We always, when we factorize, we choose that type of numbers that when multiplied give you this number, that when add subtracted then gives you this number with the z coefficient, okay, with the middle coefficient. Okay, so now here when we look at them, z is common between them, so z minus 5 is an answer, and 4 is common from these two, so z minus 4 into 5 is 25. z minus 5 first we will write. In the second bracket we will write z plus 4. So these are our solution set. Number 8, in which 2z cube plus 9z square minus 11z minus 30 is the expression, and we are going to check out, because this is the 30 number and like 30 is the multiple of 1, it's the multiple of 2, it's the multiple of 6, it's the multiple of 10 and 5. First we will check out it on 2. Okay, gives you 0 as a result, so we will consider this 2. Write 2 in synthetic division, then 9 minus 11 and minus 30. Here we also have to write 2 because it satisfied the given condition. 2 into 2 is 4. 4 plus 9 is 13. 13 into 2 is 26. 26 minus 11 is 15. We have not to put the minus sign here. Why? Because we have to put the sign that is with the bigger number. 15 into 2 is 30. Our answer is 0. Okay. So for this polynomial expression, we have the first root is z minus 2, and the second expression is 2 into z square plus 13z plus 15. So we are nothing to do with this one, it's simplified already. We are going to do somewhat with this one. 15 into 2 is 30. Okay, so now we need two numbers for this 13, so that we add and subtract those number and we get 13 as a result. 10 into 3 is 30. So when 10 and 3 are multiplied, we get 30, and when 10 and 3 are added, then we will get 13. Okay, now it's easy to factorize. Take 2z common from this. We will be left with z here, and 2 into 5 is 10, so here. Now take 3 from this. 3 into 5 is 15. Write the common expression first and then the uncommon expression. This is the solution set of question number 8. Part number 9 is z square minus 7z minus 8. For 8, we have to check minus 1, plus 1, 2, 4 and 8. Okay. Minus 1 is satisfied on this. It means it is the root of this expression. Now we will do the synthetic division. 1 minus 7 minus 8. Write 1 here. 1 into 1 is 1. Plus into minus is minus. Minus 7 minus 1 is minus 8. We are adding because both have the same sign. So 8, and the bigger number has a minus sign, so minus. Minus into minus is plus. 8 into 1 is 8. 0 is the answer, as because the number is same and the sign is different. So our first root is z plus 1, and our second expression is z minus 8. So this is the solution set of question number 9. Number 10 is 4z square minus 7z minus 11, and we are going to check again minus 1 plus 1 on it, because 11 is such a number that it can be only in the table of 1 and it can be only the multiple of itself. You can see on the calculator. So we are going to do the synthetic division here. 4 minus 7 minus 11. Okay, here is minus 1. 4 into 1 is 4, plus into minus is minus. 7 minus 7 and minus 4 both have negative sign, so we have to do the addition operation. 7, 8, 9, 10, 11 minus the bigger number as minus, so put the minus here. Minus into minus is plus. 11 into 1 is 11. Cancel out, put 0. The root of this equation is z plus 1 and the second one is 4z minus 11. This is the solution set of part number 10. We know that completing square means a plus b whole square or a minus b whole square, which is always equal to a plus b. For example, whole square is equal to a square plus b square plus 2ab, or if it is minus in between them, then here it is minus. So this form is already done. This is already here, z square. Now this we have to break, minus into 2. We are going to make this middle as this expression, 2 into a into b. Minus 2 into what? Into z. This is the z square, a square. So this also has a, so we have to write a here. Okay. And this also has 2, so minus 2 is here. Now this one, 2 into 3 is 6, so this is 3. So automatically when the instead of b we have written 3, it means that we are going to square the 3. And when we are squaring the 3 in this expression, we have to subtract it as well. And plus 2 is equal to 0. Now that this whole is the expression of a square plus b square plus 2ab, we can write it as a plus b whole square or a minus b. This is the expression of a minus b, so we have to write it z minus 3 whole square. Here we have to write 3 into 3 is 9 plus 2 equals to 0. This is minus 7 equals to 0. It can be written as this. Now putting square root on both sides, plus minus. It will be z minus 3 and it will be plus minus square root of 7. The answer will be minus 3 will be shifted here. It will be 3. Be 3 plus minus square root of 7. This is the solution set. Solution set can be written as 3 plus square root of 7, 3 minus square root of 7. Okay. For this we have to multiply this whole expression with the 2, minus 2. Multiplying with minus 2. So what will we get? Minus plus. This minus and this minus will make it plus, and 2 and 2 will be cancelled. The answer will be z square here, and it will be turned into 5 into 2 is 10z, and plus minus is minus 2 into 2 is 4. Okay. Now this is the expression that we need to change. This is a square and this is 2ab form. We have to change it into 2 into 5 is 10. So it means that this is 2ab form. A is z and b is 5. So add and subtract 5 square. Because adding and subtracting anything to any equation doesn't make any difference. This whole a square plus 2ab plus b square will turn it into a plus b whole square. 5 into 5 is 25. Minus 25 and minus 4 is minus 29. We'll shift it towards this side. Now we'll apply square root on both sides. So it will be cancelled. Now we'll shift this 5 towards this side. This will be minus 5, and our solution set will be minus 5 plus square root of 29 minus 5 minus square root of 29. This will be our solution set. Part number 3 is 4z square plus 5z equals to 14. First of all, we will bring 14 towards this side. Now we will divide this whole with 4. 14 by 4. They both are the multiples of 2. 2 into 2 is 4. 2 into 7 is 14. So we will write it like this. 7 by 2 equals to 0. Completing square method, we have to solve it. Now we have to make this one as 2 into AB. 2 into AB. A is obviously Z, but B, there is a confusion in B. 2. Now 5 will be written in the numerator, but in the denominator we want such number that will give you 4 as a result when cut it out. For example, 5 by 8. When 8 is cut out with 2 to 1, 2 into 1 is 2, 2 into 4 is 8. Then it will give you 4 as a result. So we will write 8 here. Get it? So now it makes the form of 2AB. As this makes the form of 2AB, we will add and subtract it with the 5 by 8 square because we need to complete the formula. Okay. This whole will take the form of formula A minus B whole square, and this will be written 5 into 5 is 25 and 8 into 8 is 64. 7 by 2. As we know that 2 into 32 will give you 64. So we will multiply the numerator and denominator with 32 to make the denominator same. 7 multiplied by 32 and 2 multiplied by 32. Seven into 32 will give you 224, and 2 into 32 will give you 64. So now we have the denominator same, and in the numerator we can write minus 25 and minus 224 will give you minus 249 divided by 64 equals 0. Shift this to the other side. Now put the square root on both sides. It will be cancelled. But it won't be. Yeah, for 64 it can be cancelled. 249 the square root, and in the denominator square root of 64 is 8. So we'll write it like this. Shift minus 5 by 8 towards the second side. When we shift this towards this side, it will be turned into positive. 5 by 8 plus minus square root of 249 divided by 8. As the denominators are same, we can write it like this. Okay. So our solution set will be 5 plus minus square root of 249 divided by 8. Okay. Part number 4 is z square equals to 5z minus 3. We will shift it towards one side first. Now we will put z square and minus 2 into 5 by 2 into z plus 3 equals 0. See, 5z can be written into 2 into 5 by 2 into z. Why? Because when 2 and 2 will be cancelled, we will get 5z again. So this is why we need to write it like this. We need this form. Okay. A square minus 2ab. Now what we need is b square. So adding b square and subtracting b square. This whole will make it the form of z minus 5 by 2 whole square. 5 into 5 is 25, 2 into 2 is 4. In the denominator of 3 there is 1 and the denominators are not same, so we will multiply it with 4 to make it same. Four into 3 is 12, 4 into 1 is 4, minus 13. Now shift it towards the other side. Apply square root on both sides. This will be cancelled. And from this side, square root of 13 cannot be simplified and square root of 4 is 2. Shift 5 by 2 toward the other side. Denominators are same, so the numerators can be expressed like this. Our solution set is 5 plus minus square root of 13 divided by 2. We have done question number 1 and 2 with all parts. Inshallah in the next video we will cover question number 3 and 4. तब तक के लिए जा रहे हैं, खुश रहें, शादाबाद रहें, हमें दुआओं में याद रखें. अल्लाह हाफिज़.